Okay, you take the degree exactly the same plus the minute divided by 60 plus the second divided by 3600. You put in the calculator and that's it. Of course, you truncate or truncate around your answer to the near thousands, so 4 decimal place, get 432 because the next digit is 6, it's bigger than 5. Okay, this is completely backward. You take the decimal part of the given number, so you delete mentally 9, get the whole part, and multiplication by 60. One more time, the answer is 23.52. You take the decimal part of this answer, is 0.52, and multiplication one more time by 60, and give 31.2. Conclusion, the answer is 9 degrees, stay the same. 23 minutes, get the whole part of the first calculation, and 31 seconds, get the first part of the second calculation. This is super easy. It's just apply the formula of the conversion degree to radian. We have the formula here. It's basically multiplication by pi and divided by 180. I did both. I get the answer. 5 pi over 6 is the first one, and the second one is 5 pi over 4. Okay, in this example you apply both formula. The formula for the conversion degree to radian in the first one, and the formula for the conversion radian to degree. That's just the formula. That's it. Okay, this question number 5 super easy. Is sketching the angle gets given, in this case is 315 degree. 315 degree is bigger than 270, so it's in between 270 and 360. Okay, therefore in the fourth quadrant, exactly in the middle, beset the fourth quadrant. Of course you rotate counterclockwise. In this case, well, it's a little bit more complicated because a negative angle and also is expressed in radians. But if you want, you convert to degree. Case multiplication by 180 divided by pi. The answer is negative 315. So it's the same position, 315, but rotate counterclockwise. Then the angle lie in the first quadrant, exactly in the middle, like a 45 degree. So you express it like a positive notation. Okay, there are two different ways to analyze this. One way is using directly a radian, so negative 17 over 9 pi. You separate like a 9 over 9 is 1, negative pi, minus 8 over 9 pi. Well, just in this case, or directly you convert to degree, okay, it's divided by pi, the pi cancel, multiplication by 180. Actually, the answer is negative 340 degree. Okay, now look here, be careful. I saw in this circle 24 division. Let me see, 1, 2, 3, 4, 5, 6. 6 in each quadrant multiplied by 4 is 24. So basically, each division is 360 divided by 24, 15 degree. 15 degree. So now my angle is, of course, clockwise rotate, and lie between the second and the first division and the first quadrant. que, it's approximately, it's a negative 330 and negative 345. The 340 is okay, it's acceptable in this position. Okay, in this question, sketch negative 45 degree in a standard position. Okay, I did that. Look. And then sketch the coterminal. Coterminal is the angle that has the same terminal side. But in this case, it would be counterclockwise. So negative 45 is clockwise because it's negative, and the coterminal is the same. O sea, the angle que have the same terminal side, pero in this case clockwise, counterclockwise, sorry. But it's easy. Determine the value because you take 360, que es the entire circumference, the entire circle, minus 45 degrees is 350 degrees, and that's it. Okay, in this case it's opposite. Number one is you sketch the angle 11 pi over 6 in a standard position, positive, counterclockwise. Actually, in degree would be 330 degrees. But it's not important. Now, the coterminal associated with the same, so the angle que has the same terminal side, but in this case, clockwise, is negative pi over 6. Okay, sketching the angle theta equal 510 degrees. 510 degrees is bigger than 360. You're subtracting 360, the answer is 150 degrees. And its interpretation then is 1 revolution and 150 degrees. Everything counterclockwise. Okay, this is similar sketching. In this case, negative 15 pi over 4, negative angle. Therefore, the rotation is clockwise. Entonces now, you divide, because 15 over 4 is improper fraction. You divide 15 over 4, and when you convert to the mixed number, it's 3 over 4. So you separate, like a minus 3 over 4, minus 3 pi, que es el quotient, and minus 3 pi over 4, que es the remainder, over the divisor. Okay, and negative 3 pi is 1.5 revolution, clockwise. And 3 over 4 is negative 135 degrees. So basically is 1.5 revolution clockwise and 135 in the same direction. Okay, one revolution, half revolution plus 135. So basically lie the angle, this angle lie in the first quadrant is equivalent to 45 degrees, pi over 4, positive. Okay. In this question we have the angle theta equal 570 degrees. Number one is sketching. So you're subtracting 360 is 210. Okay, 210 is the angle that lie in the third quadrant. So basically we have one revolution, counterclockwise because it's positive, and also 210 degrees in the same direction. So it's easy. There's one revolution plus 210. And 210 lie in the third quadrant. Find the angle. So now I find coterminal. Coterminal is when it's negative, no? It's in the opposite direction, so clockwise is 150, no? Because it's 180 minus 30, negative 150. And the other coterminal, but in the positive direction, is just 210, exactly we see before. Okay. In this question, 17 pi over 6, positive. Entonces you divide 17 divided by 6. Entonces you see que es 2 the whole part and 5 over 6 the fraction part. Basically 17 pi over 6 is equal to pi, que is 1 revolution, counterclockwise of course, plus and 5 pi over 6 is 150 degrees in the same direction. Okay, it's easy sketching. Now, the coterminal. Bueno, the coterminal positive es obvio que es 5 pi over 6. And the coterminal negative is subtracting 2 pi minus 5 pi over 6, que is 7 pi over 6, of course, with the negative sign, because it's the, in this case, would be clockwise direction. Okay. Number 1, so A question is find the angle between 0 and 360, que is coterminal with the 1015. Okay, you can subtracting several times, 360, 360, 360, but much better. When it's too long sequence, you divide by 360, you get a decimal, 2.8 something. You remove the whole part, because the whole part represents the revolution. And you take the fraction part, the decimal part, and multiply again by what? 360, you get new angle in degree, que es ese coterminal. The coterminal is 295 degrees. Cool. The second question B is 27 pi over 10. Well, one more time, 27 pi over 10, you separate into parts. Basically, it's 20 and 7, no? The 20 divided by 10 is 2, 2 pi is 1 revolution, plus 7 pi over 10 is the coterminal, positive, but on radial. Okay, the formula for compute the arc length is S equal theta, is the angle in radian, very important, in radian, no degree, multiplication by the radio. In this example, the circumference is 2 pi. Then we can infer que the radius is 1. Okay, so now actually is 5 over 6 times 2 pi. Actually is 5 pi over 3. Multiplication by 1 is the same. This is the arc length, 5 pi over 3. Okay. This question is very similar. In this case, we can, well, we can know, it's given que the radius 2. Entonces, the theta is 3 over 8 times 2 pi. Wow, actually it's 3 pi over 4. So now multiplication is the formula for the arc length. S is equal R times theta in radians. 2 times 3 pi over 4 is 3 pi over 2. Okay, in this example, we're using the same formula, but we are using Bauer because the information that's given is 22 centimeter is the arc length. And the central angle, theta, is 2.9 radian. Cool. Same formula, but in this case you isolate the radio. The radio is 22 divided by 2.9. You get the decimal, however they want, only the approximation using the nearest tenth, okay, 7.6. Okay, this is a bicycle problem. Okay, the information gets given is the diameter of the wheel, okay, 58 centimeter. Therefore, the radius a half is 29. One more information is given. Well, it's giving It's giving nothing. It's giving first of all, I want to find the function state the relationship between x, x is the displacement, and linear units. In this case is centimeter. Entonces es, this is, I suppose que x is s, length, it's the same, right? Now data is equal to x over 29. Under the supposition que the displacement is 50 centimeters. Bueno, plugging in. Plugging in is 50 divided by 29, but this is in radians. In order to convert to degree, you multiply by 180 and divide by pi. Everything using calculator, decimal approximation of pi. Entonces, you round to the nearest 10, so 98.8 degree. It's a rotation of the wheel. And that problem we have a gear. So we have two, smaller and large. Okay, the radius given. But I know that when it's moving, the R length is equal each other. Using the formula and two conditions, theta 1 R1 is equal theta 2 R2. And we discover the connection between theta 2 and theta 1. The radius is 29 divided by 43. This is my first equation. Theta 2 is equal to 29 over 43 multiplication by theta 1. Suppose now 1 revolution. Theta 1 is equal to 1 revolution. How many are length? How many degrees? How many radians? Sorry. We obtain under this condition in the theta 2, que es the large. Entonces, substitution. 29 times 2, 58 pi over 43. Cool. Okay, 20 is easy. 20 is just everything is given. It's given the radius 3.5 meter. It's given the angle in radian, nice, 0.9 radian. And find the area of the sector of circle que corresponde with the angle. Entonces just plugging in the formula. 1/2, 3.5 squared times 0.9 multiplication and round off your answer to the near 10 is 5.5. Okay, this is more interesting. This is application problem. We have a windshield wiper sweep out a sector of the circle with a central angle of 135 degrees. Entonces now, according to the picture, I see the angle is 135. When I know that the formula needs plugging in radians, you convert immediately to radian divided by 180 and multiplication by pi, 3 pi over 4. Okay, cool. Because the area total, or the area is equal to the area 1, que es the area associated with the big radio, que the big radio is 51 plus 33 is 84 centimeter. And you compute that, or not necessarily compute that, you put a formula, you plug it into the formula, entonces we have 1/2 as a common factor. Theta is common in both scenario, que es 3 pi over 4, and you subtracting the radius square. 84 squared minus 33 squared. The rest is calculated. Put in the calculator, of course you round to the near thing, and that's it. This is another application problem, a little bit more interesting. Well, we have a wheel, ferry wheel, that has 50 feet centimeter, radius 25, half, and the frequency is 3 revolutions per minute. I want to call frequency F. F is equal to 3 revolutions per minute. In order to find the angular speed, the formula is 2 pi f. Entonces multiplication 2 pi times 3 is 6 pi. 6 pi expressed in decimal is you put pi in your own calculator, depending on the approximation. Your own calculator is 18 point something. You round to the near whole numbers, 19. 19 is omega. Omega is the angular speed, 19 radian per minute. Okay, radian. Okay. And linear velocity, linear speed, or velocity, no speed, because this is a scalar, is equal to the formula omega multiplication by r, r25. That's 6 pi times 25, put in the calculator. However, you get in feet per minute, but they want in mile per hour. Okay, this is Winning conversion. Winning conversion is relatively easy if you know that 1 mile is 5,280 feet. So the answer I get was 471.239. No round, no truncate. You copy exactly the same. Divided by 5,280 and multiplication by 60, because the conversion from minute to hour is 60 minute is 1 hour. You get the decimal. They want only whole number, five miles per hour. This is too easy. Es obvio que for the angle pi over 2 is 90 degrees. The terminal point is 0,1. This is super clear. Okay. The question is find the point on the unit circle given one coordinate and the quadrant. Okay. So you suppose que es unit circle. In the unit circle, the first component is cosine theta, and the second is sine theta. Now the information is given is -3/4. It's a sine. To understand a little bit, I do the triangle. Opposite is 3, adjacent is 4. I don't care the sign for a moment. I keep in mind it's 4 quadrant. Okay, now you find the adjacent. Okay, it's square root 16 minus 9, radical 7. Now cosine is adjacent over hypotenuse. In our triangle, no? It's radical 7/4. Okay, important, it's positive. Because the information is given at the beginning is theta lie in the 4 quadrant. Therefore, in the 4 quadrant, cosine is positive. Okay, this is a little bit weird. It's weird because two things. The angle is negative and it's decimal, 1.55 pi radians. Okay, to analyze this, I propose you one idea. You separate -1, que es negative pi, and minus 55 over 100 or 0.55, que es the same in decimal or fraction. I prefer fraction. When you reduce in lowest term, it's 11 over 20 pi. The angle, when you are doing the sketch, so you sketching, no? This, you have negative pi, of course, clockwise, exactly the picture indicate, and we need 11 over 20 pi. I see okay, each division in the unit circle is 1 over 20. Entonces 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 over 20. Each division is pi over 20. And negative 11 is in the same direction, so clockwise. 11 division, no? A little bit weird, I understand. Now, the rest is easy. You put in the calculator. Sine -1.55 pi and cosine, sorry. Cosine. This is cosine. Sorry, cosine. Let me fix that. No. It's super easy, super easy. Because in both triangles, I suppose the hypotenuse is 1. Therefore, the distance d and the first one is the sine. Sine 30 degrees is 1/2. And the second, well, entonces A es the cosine because es the adjacent. Entonces y cosine 30 degrees es radical 3/2. No? Okay, the first part is super easy. Sketching the negative 45 degree. Negative 45 degree is in the clockwise direction, here in the middle of the fourth quadrant. Okay, now A and B. A and B are positive both because it's a length. Okay, so this segment is radical 2/2 and this segment is radical 2/2. Of course, this is down. So when you write component, no length. Entonces radical 2/2, comma, negative radical 2/2. Because lie, of course, in the fourth quadrant. Okay, this is easy. Okay, cosine negative 45 degree. Bueno, cosine is even function. Entonces es positive. Cosine positive 45 degree que es radical 2/2. Tangent negative 45 degree. Tangent is odd function. Entonces negative outside. Tangent 45 degree que es 1. Actually, entonces es negative 1. And cosecant negative 45 degree is equal 1 over sine. Sine is odd function again. Now the sine, the negative go outside. Sine 45 degrees radical 2/2. Entonces 1 over negative radical 2/2. Bueno, reciprocal, flip it. And rationalization, radical 2, radical 2. Then the answer is minus radical 2. Okay, now the angle is negative 5 pi over 6. Is in the clockwise direction. Is more than 90 degrees, therefore lie in the third quadrant. Okay, and the component of the length of this segment A and B is radical 3/2 because it's similar to the cosine. Cosine in this case is 210 degrees. You analyze like a positive direction. And B is like a sine que es 1/2. Of course it's down. Entonces in the component, when you write the point P is both negative. Negative radical 3/2 comma negative 1/2. Okay, compute cosine negative pi over 6. Well, cosine is even function. Therefore, the negative disappear. However, in the second quadrant, when it's positive 5 pi over 6, the cosine is negative. And the reference angle obviously is pi over 6. Entonces es radical 3/2, pero negative. Cosecant is the reciprocal of sine. Sine is negative outside. If 5 pi over 6 is in the second quadrant, entonces es positive sine. But we have a negative go outside, entonces negative 1/2. I know que es 1/2 because the sine pi over 6 is the reference angle is 1/2. That's a negative 2. And cotangent is super easy. We apply the cotangent identity, cosine over sine, division, just division, the first answer, minus radical 3/2 over the second answer, que es negative 1/2, is positive radical 3. That makes sense because theta lies in the third quadrant. In the third quadrant, the cotangent and tangent is positive. Oh, this is super easy. Sine 5 pi over 6. 5 pi over 6 lie in the second quadrant. Actually, it's 150 degrees. And the sine, well, the the reference angle is 30 degrees pi over 6. Sine is 1/2, but the sine is positive in the second quadrant. Well, it's relatively easy to sketch 0.3 pi, and pi minus theta is 0.7 pi. Each division is pi over 20 because you have 20 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Multiplication by 220. Pi divided by 20 is the value for each division, is 0.05 pi. So 6 divisions is 0.3. 1, 2, 3, 4, 5, 6. And 14 division is 0.7. 6, 7, 8, 9, 10, 11, 12, 13, 14. Exactly. Okay, this is relatively easy so you know that property. So you know that cosine pi minus theta is equal to minus cosine theta. Sine pi minus theta is equal to positive sine theta. And tangent pi minus theta is equal to minus tangent theta. That's a super easy identification here. Okay, now consider the equation, the part B. Replace 0.3 pi, okay, this, okay, the terminal point pi minus theta and the terminal point theta have the same y coordinate, therefore the sign is positive. But one of the reflection of the another across the y-axis and the part B are true no matter what angle theta is chosen, as long as the tangent value are defined. This is clear. In this question, compute the secant 225 degree. 225 degree lie in the third quadrant. In the third quadrant, the secant is negative. Because remember, the secant is the reciprocal cosine, and cosine in the third quadrant is negative. And then the reference angle is 225 minus 180, 45. And the value is the same as secant 45 degree is equal 1 over cosine 45 degree, que es radical 2 over 2, reciprocal es radical 2. But adjust the sign. Secant 225 degree is minus radical 2. Tangent no, tangent is positive. In the third quadrant, everything is positive when the tangent is positive. The reference angle is 45, tangent 45 degree is 1, therefore the tangent 225 degree is also 1. Okay, the angle in this example is minus 2.10 pi. Negative 2.10 pi is equal minus 2 pi minus pi over 10 in fraction. Each division is pi over 20, okay, 0.05 pi. Therefore, pi over 10 represents 2 divisions. So the angle, to sketching the angle, is 1 revolution clockwise and 2 divisions in the same direction. Exactly idea here. The rest is calculated. Secant. Suppose that your calculator have no secant, you compute like reciprocal cosine, and cotangent is reciprocal tangent. Well, you have a 960 degree divided by 360 is 2.6. Repeated. You take the fraction part, the decimal part is 0.6. Repeated multiplication again by 360, and we have 240. 240 is coterminal to the 960. Now the reference angle is 240 minus 180 because 240 lie in the third quadrant, the 60. You compare the cosine 60 get 1/2. And you adjust the sign according to the quadrant. See, this 960 is coterminal to 240, and 240 lie in the third quadrant. Of course, the cosine is negative. The second is pi tangent negative pi over 4. You take advantage. Que the tangent function is odd function, you put the negative outside. I know very well that tangent pi over 4 is 1, therefore it's negative 1. Okay, this is easy. You know the sine pi over 4 is radical 2 over 2, and cosine pi over 3 is 1/2. Substitution. Find the simplification. Manipulate. You simplify the 2 in the bottom and the top, and finally rationalize. Multiply by the conjugate, 1 minus radical 2, the conjugate is 1 plus radical 2 in the top and the bottom. The rest is multiplication, FOIL, and that's it. The answer is negative 4 minus 3 radical 2.